I'm faced with a life or death choice. I'm a geologist about to explore the solar system, and I've got to decide, do I want to take an extra litre of water for safety or my geological hammer? Well, let's compare the merits. Water is like the Swiss Army knife of space exploration. It's H2O, hydrogen that I can use as rocket fuel, oxygen that I can breathe. I can recombine the two in a fuel cell that will give me electricity and also give me liquid water to keep myself hydrated, rehydrate food, and maybe even grow some food on the way. But what's the point in taking all these provisions on our journey if we can't do any science when we get there? So which one are we going to leave behind? Well, I say we've got to learn to leave the water behind. We've got to learn to live off the land. Now, not in a Bear Grylls, come on, we'll jump off the cliff, it'll be a bit of crack sort of way. I'm talking about mapping the water resources of the solar system and planning our trips very carefully. And it turns out that understanding how particles behave in collisions is the way that we might do it. Now, that collision there, it wasn't a member of the audience, it was a pollen grain that hit and flew to the back of the room. But that ball kept going with the same momentum after the collision because there was a huge contrast in the mass of the particles. Just like when I try and collide the particle with the mass of the entire building, that particle keeps going. It doesn't lose its velocity because there's a huge difference in the mass. But watch what happens when I collide with something of exactly the same mass. It doesn't go as far at all. It's lost a huge amount of its momentum. It's transferred its velocity very effectively. And when we're looking for water, many of the places we're going to look are barren and desolate, like the surface of the moon. But these are places that are constantly bombarded by gamma rays, cosmic rays, that liberate neutrons in the lunar soil. Now, most of them ping off dense iron and silicon and oxygen and magnesium, the ingredients of basalt. And when they ping around like they're in a pinball machine and then come up out into space, we can measure the velocity, and they're fast, energetic neutrons. But when we fly over certain areas, like the poles and craters that are in permanent darkness, what we find is the neutrons have slowed way down. They've been through multiple collisions with something of exactly the same mass. Now, the most abundant thing in the universe is hydrogen, protium, as we call it, because it's one proton and one electron. Now, the weight of the electron, you can forget it. It's like the weight of my fingerprints on this ball. So, probably what's happened is that those neutrons have collided with multiple hydrogen atoms. It can't be hydrogen gas because that would be long gone. It must be bound up with something else, which is oxygen, H2O. So find the slow neutrons, you find the water. I know what I'm not leaving home.